Let us discuss another example about to work. Imagine a seesaw in the playground. The healthy kid weighing 50 kilograms is seated 2 meters to the left of the center of the seesaw, and another lighter kid weighing 40 kilograms is seated on the other side of the seesaw. If the two kids are to be balanced on the seesaw, how far to the right should the lighter kid seat on the seesaw? This example uses the concept of rotational equilibrium, since the aim is to find out how to balance the seesaw. This means that the net to work is equal to 0. Let us see all the torque present in this example. The two kids exert a force on each end of the seesaw because of the pull of gravity, so net to work is also equal to torque from healthy kid plus torque from lighter kid, and this will be our equation number 1. The force exerted on the side of the healthy kid is equal to mass, which is 50 kilograms, times acceleration due to gravity, which is 9.8 meters per second squared, which is equal to 490 newtons. This force is exerted towards the ground, so this means that it is exerted 90 degrees with respect to the seesaw. Using the equation for torque, which is force times distance times sine phi, and by substituting the values, we get 490 newtons times 2 meters times sine 90 degrees, which is equal to 980 newton meters. Remember that torque is a vector, so direction is important. This force on the side of the healthy kid will try to rotate the seesaw in the counterclockwise direction. This means that the torque is positive. On the other side of the seesaw, the force exerted is equals to the mass of the lighter kid, which is 40 kilograms, times the acceleration due to gravity. The force on the right side is equal to 392 newtons. The direction of the force is also straight down, so it is 90 degrees with respect to the seesaw. Using the equation of torque and substituting the values, we get torque is equal to force, which is 392 newtons, times distance. Now since it is the unknown, we will use r times sine 90 degrees also. Since the torque on the right side will try to rotate the seesaw in the clockwise direction, the torque will have the negative sign. Substituting the values of the two torques to equation number 1, we will get net torque for 0 is equal to positive 980 newton meters minus 392 newtons times r. Now we will solve for r. Using algebra, we will end up with the equation of r is equal to 980 newton meters over 392 newtons. We cancel out newtons and it will leave us with the unit of meters, so r is equal to 2.5 meters. The answer would be, the lighter kid should sit 2.5 meters to the right of the center. Let us
Created using Powtoon.